Hello everyone. This is a presentation about the design of a high gain unconditionally stable amplifier, which is topic A of the proposed podcast. The design on the amplifier will be focused on achieving the maximum available gain, which is possible as we are assuming unconditional stability. To do so, we are going to follow the following steps.
The first step is to choose a transistor whose S parameters for a given frequency ensure unconditional stability. For that purpose, the following conditions must be accomplished. The determinant of the S parameter matrix must be less than 1, and the roll stability factor, K, must be greater than 1. Step 2 consists of the design of the matching networks. We will select perfect input and output matching to guarantee a transduction gain equal to the MAG. In order to achieve this, we will use this formula to obtain the source and load reflection coefficients. On the other hand, the input and output reflection coefficients must be the conjugate value of the actual reflection coefficient of the source and the load, respectively. Finally, in step 3, the MAC value will be directly calculated from the S parameters and the roulette factor. This formula is obtained by applying a conjugate match in the transducer gain formula.
In order to complement the previous explanation, a visual example will be given in this slide as the maximum gain design of the unconditionally stable transistor whose S parameters are shown for a given frequency, with the corresponding source and load reflection coefficients drawn in the Smith chart. Since the device is unconditionally stable, the constant available and power gain circles are fully contained within the Smith chart and collapse to single points, which are related to the MAC value achieved with simultaneous conjugate match. Following the steps described previously, it is possible to compute the source and load reflection coefficients and draw them into the chart according to their module and phase. The resulting points correspond to the maximum available gain, or the MAG, in both cases. Finally, these coefficients are transformed into the corresponding source and load impedance, which completes our design.
The proposed problem consists on the design of a microwave amplifier using the transistor that can be shown in the screen. This transistor will operate at 2 GHz at MAG conditions. The S parameters are shown in the slide. The problem consists on analyzing the stability of the transistor, identifying the source and load reflection coefficients and the input and output reflection coefficients on the Smith chart, and finally computing the maximum available gain, MAG value.